You look at this, what do you see? A colorful compact box that looks like it belongs in a toy store? Or a precision machine capable of creating detailed functional parts? And right up front, full disclosure, Geeetech sent me this M1 Mini and some of their filament to test for this video. However, this was done under my strict review policy. That means Geeetech has no influence on the content you're about to see, they get no preview before it's published, and this entire review reflects my own transparent and honest findings. And there's the kicker. It currently sells just for under 160 bucks. Honestly, when I first saw the Geeetech M1, I dismissed it. With its small size and bright plastic shell, I thought, that's a toy. It just wasn't on my radar as a serious piece of equipment for a 3D printing enthusiast. But that got me thinking, is it just a toy or is it a powerful tool hiding in plain sight? And more importantly, who is a printer like this really for? Is this the perfect first step for a complete beginner? Is it a capable little workhorse for a seasoned enthusiast who needs a second machine? Or could this actually be the FDM printer that tabletop gamers have been looking for to rival resin quality without the mess and fumes? Today we are going to answer those questions. We are going to push this little machine to its limits, from unboxing to high-speed prints and detailed miniatures, to find out if the Geeetech M1 is a toy, a tool, or something else entirely. Let's find out, and our investigation starts as always inside the box. Intro check complete. Engaging print protocols. Let's start with unavoidable unboxing and see what we get. There's a quick start guide and then another small brochure with additional instructions. We will see what it is when I set up the printer. A spool holder, then a small ring of filament to do the first test prints. Next there's a PTFE tube and some tools. Besides an Allen key, a wrench, a needle and tweezers to clean the nozzle. The back also contains a spare nozzle and an SD card. Furthermore, in the white box we get a 24-volt power adapter for the printer and a power cable. Finally, we have the Geeetech M1 Mini 3D printer itself. So, the unboxing is done, and yeah, with its bright plastic housing it definitely looks like a toy. We've confirmed the first impression. But does it assemble as easily as a toy, or are we about to run into the complications of a real tool? Setting up this little 3D printer is as easy as following the steps outlined in the quick start guide. First, we remove the packaging from the M1 Mini. Then we have to cut the cable tie that's securing the print head, taking care not to cut the wires inside. Now the Teflon tube has to be installed. One end goes into the filament run-out sensor and the other end is pushed into the print head. Make sure to push it until it doesn't go deeper, otherwise the filament may get stuck on the way to the hot end. The filament holder is installed at the side. It only supports 0.5 kg spools, but there's an alternative provided by Geeetech, which we can print using the M1 later, that can hold larger spools too. As a final step, we have to check if the X and Y axis belts are loose, eventually adjust the belt tension following the detailed instructions given on the add-on paper. And that's it. The physical setup was straightforward, just cutting a few cable ties, mounting the spool holder and checking the belts. So far it's certainly as easy as a toy. But the hardware is only half the story. The real complexity often lies in the software and initial calibration. Let's see if powering it on and leveling the bed is just as painless. Ready for power on? Let's plug in the power adapter and turn on the M1 Mini. We should see the lights turn on and see the menu to operate the printer on the LCD screen on top. Before we prepare the first 3D print, we have to level the hotbed. There's a manual mode, but for convenience an auto mode as well. Turn the knob to select auto level and press it. Oh, okay, I overlooked one cable tie. Let's try it again. The printer homes all three axes, cleans the nozzle on the silicone pad at the back and then starts to probe the bed at 16 points. The nozzle cleaning makes sure that the probing is as accurate as possible. When finished, the display will show Geeetech M1 ready. Otherwise, it shows an error that we have to troubleshoot. But a perfect first layer is the foundation of every great print. So, after seeing that successful 16-point auto level, I wanted to put it to a serious test. I filled the build plate with a huge single layer square sliced at super fine 0.1mm layer height. The result was okay, but as you can see, there are some small gaps where the lines didn't perfectly fuse together. This suggests that while the auto-leveling gets you very close, it might struggle with a first layer that fine across the whole plate. However, reprinting that same test at more standard 0.2mm gave a flawless result. A perfectly smooth, solid surface. That's a great tip to know. For this printer, a 0.2mm first layer seems to be the sweet spot for reliability. Before I explain how to configure the slicer to slice our models, let's check if there's already a test model on the SD card to do a first test print. I'd recommend making a copy of the microSD card so we have the files in case the card fails one day. But easy setup means nothing if the print quality is bad. The SD card already has a Banshee on it sliced by Geeetech themselves. Can this printer deliver a decent result right out of the box in under 30 minutes? After inserting the microSD card in the slot next to the display, I select the Print from Media. There are 3 pre-sliced G-code files. How else could it be, start with the famous 3D Banshee. The file name suggests that the print should last just under 30 minutes. After selecting it by turning the knob, the print is started by pushing it and confirming to start the print job by selecting Print and pressing the knob again. The M1 Holmes heats the nozzle to 140 degrees and then swipes it multiple times through the silicone nozzle cleaner at the back of the build plate. The hotbed and nozzle are heated to temperatures set in the G-code and it starts to print the 3D Banshee. The M1 not only finished the print in 29 minutes, but the result looks great too. If I had anything to complain about, it would only be that the chosen layer height of 0.25mm leads to this unsightly staircase effect, that the Z-seam on the chimney is too pronounced, and a minimal stringing which is really not worth mentioning. I can't see any ghosting or ringing artifacts, and the overhangs are also almost perfect. There we have it. In just 29 minutes we have an almost perfect Banshee with no real issues to speak of. So it looks like a toy, sets up like a toy, but it prints like a serious machine. But why did it print so well and so fast? What's going on under this plastic shell that allows a printer this small to perform so well? Now that we've seen the printer in action, let's take a closer look. The case feels stable and the mechanics look promising too. The printer allows access for maintenance from the front and back. It has no door. Because of this, it is somewhat noisy with this open design. On the left, we have a USB Type-B female connector with which you can connect your laptop directly to the printer to send G-code files for printing. I would have preferred to see a modern USB-C socket here. Next to it is a power inlet and on the right the power switch. A little higher on the front left is a filament run-out sensor. It will pause printing in case it detects this. What I like is the fact that it can be disabled using the LCD menu on top of the printer. The menu on the LCD is structured in logical sections and the rotary push knob makes it easy to access and navigate through it. Let's step through. Push the knob to enter the menu. There we have Print from Media, Motion, Prepare, Configuration and an About section of the printer. The printhead carries a direct drive extruder using a NEMA 14 stepper motor, which should enable it to print softer filaments like TPU. I already have a functional TPU print in mind to test that. On the heated bed is a magnetic textured PEI plate. At its back it has a cutout through which the silicone nozzle cleaner is visible. Though you could level the Geeetech M1 Mini manually, it also has auto bed leveling that measures the print bed at 16 points. You don't need to do it for every print. Do an auto leveling when you feel that your prints start to fail. And while the idea of combining auto-leveling with an automatic nozzle wipe is great, it brings me to 2 firmware refinements I'd love to see Geeetech implement. First, the temperature during that nozzle clean. It's set to 140 degrees Celsius, which feels too low to get some filaments properly soft for a clean wipe. Bumping this to at least 160 degrees Celsius, or ideally letting the user set it themselves, would make this feature much more reliable. Second is a homing sequence when you start a print. The printer homes, cleans the nozzle, heats fully and then it homes a second time. This is risky. Homing with a fully heated nozzle can lead to a bit of oozed filament on the tip, potentially causing an inaccurate Z height for that critical first layer. The process should really be home, clean, heat, and then print. These aren't deal breakers, but they are kind of process refinements that would elevate this printer from good to great. During printing, 3 NEMA 17 stepper motors with their 200 steps provide enough power and precision to drive the X, Y, and Z axis. So, we now know the secret sauce: a solid Cartesian motion system with 3 NEMA 17 motors for precision, a powerful NEMA 14 direct drive extruder for filament control, and reliable outer bed leveling. This thing is packed with the hardware of a real tool. And speaking of the high quality hardware and electronics that make a tool like this possible, it's the perfect time to thank this video sponsor, PCBWay. PCBWay is best known for its high quality PCBs. You can get 10 PCBs starting at $5, which is awesome to give your DIY projects a professional touch. Besides PCBs, PCBWay offers CNC machining and 3D printing services, as well as sheet metal fabrication and injection molding, making them a perfect choice no matter if it's for small DIY projects or larger companies. If in doubt, give them a try, you won't regret it. A huge thank you to PCBWay for supporting the channel and helping makers create their projects. So, we've established that the M1 is packed with great hardware, but great hardware is useless if you can't tell it what to do. How easy is it to set this printer up in a slicer to create our own files? Is it a plug-and-play experience or a nightmare of custom profiles? Setting up the slicer is a no-brainer if you use a recent version of Orca Slicer, because it already has profiles for several Geeetech 3D printers, including the Geeetech M1 Mini. The only thing you need to do is open the printer settings, enter M1 into the search box, and it's there. The M1 has a 0.4mm nozzle, so just select that, confirm, and you're all set. If you prefer Ultimaker Cura, then the installation is a bit more complicated. You'll have to download the configuration files for Cura from the Geeetech wiki page. After extracting the files in the downloaded archive, you have to copy them to the correct path in the Cura installation directory. This requires you to confirm the UAC dialog that pops up when you try to copy them. Once done, you can add the M1 as a new printer in Cura and are ready to slice STL files using that printer profile. And there's our answer. In Orca Slicer, it's an absolute no-brainer with a built-in profile. For Cura users, it's a bit more work, but still very manageable. Now that we have full control in the slicer, let's move beyond the pre-sliced Banshee. Can it handle a real technical torture test designed to push its limits on bridging, overhangs, and accuracy? To get a picture of the print quality of the M1, especially when printing at higher speeds, I sliced the micro all-in-one 3D printer test using a layer height of 0.15mm. The print took a little longer than an hour. Although printing with a 0.4mm nozzle, the fine feature gaps print okay to 0.2mm. The two cones printed nicely too, with their tips as sharp as one can expect from the nozzle size used. The bridges are good as well, and show no sign of drooping lines even for the 25mm bridge. The M1 handles overhangs of 70% without problems, but they start to get worse at 75%. The tolerances of the two circles are okay, with 13.9mm and 9.9mm for the larger outer and inner diameter, and 7.89mm and 3.72mm for the smaller circle's outer and inner diameter. But the ultimate test for printer's accuracy and stringing control is a complex print-in-place model. So I sliced this planetary gear fidget toy to see if the M1 could handle it. I printed it at 0.2mm layer height, and right off the build plate it worked flawlessly, but I think it would have been even better printed at 0.1mm. The gears move smoothly with no bindings whatsoever. This is a huge win and proves the printer can handle complex mechanical parts. However, if I am being picky, and as a geek I am, the tolerances could be even tighter. There's just a little more play in the gears than I personally like. So, while it's perfectly functional out of the box, an advanced user might want to fine-tune their slicer settings to dial in those clearances even further. But raw technical performance is one thing. Can that precision translate into aesthetic quality? Can this little FDM printer really produce the fine details needed for tabletop miniatures and challenge the world of resin printers? I printed Geeetech's Phil A Manned Astronaut with this rainbow PLA. After roughly 1 hour 50 minutes, the print was done. The cat was printed with the Geeetech Violet PLA. Both prints look quite nice, and again, they printed without problems. Finally, I used some gray filament to print a goblin, a gnome and a gargoyle. The prints were made with a 0.1mm layer height to achieve the highest level of detail. I was curious to see how many of these figurines would fit on the small build plate. An overwhelming 25 goblins, which would finish in under 6 hours while just using 30 grams of filament. These were among the smallest prints I ever did on FDM 3D printer, and the results are satisfying. It can print an entire army of goblins with impressive detail for an FDM printer. In case you need even more detailed miniatures, you could try using a 0.2mm nozzle. So yes, it absolutely has the potential to be a tabletop gamer's new best friend. But printing an army of goblins takes hours. What's this machine actually like to live with? Let's talk about the day-to-day experience, starting with a couple of things that started to annoy me. I might remove the annoying piece of silicone near the heating bed connection with a craft knife. Before we dive into a practical application printed in TPU, let's take a look at the noise levels. I measured it at distances of 1 meter, half a meter and directly in front of the printer. At 1 meter I got about 40 to 43 dBA, which is considered relatively silent, comparable to the humming of a refrigerator. This doesn't change much at 0.5 meter, only directly in front of the printer the noise level rises to around about 50 plus dBA. This is still considered moderate and comparable to the background noise in a large office. Nevertheless, I wouldn't put it in my living room and absolutely not next to a kid in their bedroom. So, while it's not silent, it's quite enough not to be a major disturbance in a hobby room. But combined with the fiddly build plate, you can see it's not without its quirks. We've seen its precision and tested what it is like to work with, but we still haven't checked one key feature promised by its direct graph extruder. Can it handle TPU? With its direct graph extruder, the M1 should have no problems printing TPU. To test that, I print a lens cap for my Osmo Action 5 Pro using a red soft filamentum 92A TPU. The print goes quickly, and within a few minutes I have an additional protection to put over the already installed lens protection of the Osmo Action 5 Pro. And just like that, a perfect functional lens cap printed in soft TPU. So yes, it absolutely passes the flexible filament test with ease. The printer is versatile, but during all this testing I did notice one more little quirk. While I was recording the video, I noticed a soft squeaking noise as the printer heated up for a print, which was later drowned out by the component fan. Maybe it's a fan on the control board. I'm not worried about it yet, but I will keep an eye on it. Maybe you can hear it in the video. With the excellent maintenance instructions, replacing the fan should not be a problem if it fails. So, it's a minor noise that I'm not too worried about yet, especially with the great documentation for repairs. It's just another one of those little personality quirks of this machine. Okay. We've looked at everything from its performance and features to its noises and annoyances. Let's put it all together and lay out the definitive list of pros and cons. On the pro side, it delivers a good print quality, sometimes even excellent. Its speed is really good for a Cartesian 3D printer of this size. I also like the bright lighting inside the case. As we saw, it's ideal for printing miniatures and tabletop models without the hassle of dealing with toxic resin and its fumes. Furthermore, it's lightweight, not hard to find a place for it. Geeetech provides an excellent wiki with in-depth setup, maintenance, repair and troubleshooting instructions. Larger spools require a filament roller, exchanging the spool holder or feed it from a dry box. Then you may want quickly a larger build space. 100 x 110 x 100 is very limited. though it's okay for many 3D prints. The Geeetech M1 Mini has no Wi-Fi to upload and monitor the 3D printer, and with no Wi-Fi it comes that it has no camera to watch the printer remotely. You must stay close to egg on failure. So, there you have it, all the good and the bad. With all that in mind, it's time to deliver the final verdict and answer our original big question. Is the Geeetech M1 Mini a toy or is it a tool? The answer, surprisingly, is both, in the best way possible. It has a friendly, non-intimidating look and that simple setup of a toy, making it incredibly approachable. The auto-leveling just works, and with the printer profile already available in Orca Slicer, a complete beginner can get great prints in minutes. But its performance is all tool. The print quality from this little Cartesian machine is fantastic, delivering sharp details and handling high speeds without ringing. Its ability to print TPU reliably thanks to the direct drive extruder is a serious feature, and for tabletop gamers, this printer is a potential game changer. It churns out detailed miniatures with an ease and lack of mess that resin printers just can't match. Now, it's not perfect. The limited 100mm build volume is a real constraint you have to accept. The lack of Wi-Fi feels a bit dated, and yes, the fiddly build plate and the tiny spool holder are genuine annoyances. This isn't the one printer that will do everything. So, who is this for? If you're a beginner looking for the easiest possible entry into 3D printing, this is one of the strongest contenders I've seen. If you're a tabletop gamer who wants to print armies of minis without the fuss of resin, this is an absolute must-see. And if you're an experienced enthusiast like me, it's not going to be your main workhorse, but as a specialized second printer for fast, high-quality small prints, it has definitely earned a place in my workshop. It turns out the Geeetech M1 is a serious tool that has a welcome simplicity of a toy. It absolutely punches above its weight. But what do you think? Could you see this little printer on your desk? And for all the gamers watching, would you pick this over a resin printer for your miniatures? Let me know your thoughts down in the comments. If you found this review helpful, do me a favor and hit that like button and subscribe to 3D Printing Geek so you don't miss the next one. Thanks for watching, see you next here on 3D Printing Geek.